Okay, guys, I think we're going to start with this paper. This is a 2022 past paper. It's examination for school certificate. So I shall do this video in three parts. The first part will only be the multiple choice section. So I want to concentrate on the multiple choice part. So this is where I will concentrate on multiple choice. Then I will make other videos for other sections. So now we have this part, the multiple choice part. So we start with the first question. A wire. First, before we begin, I would advise, before you even look at the multiple choices, you first try to come up with your own answer. Then that's when you can compare with the ones on the multiple choices. So we have the first question. A wire has a length of 1.3 meters and a diameter of 0.4 millimeters. Which of the following instruments would be most suitable to use to measure the length of the diameter? So now, what are we going to do at this particular point? Now, this is one thing that I want you to know. The length of this is 1.3 meters, and 1.3 meters is bigger than a 30 centimeters rule, very big. So we cannot use a rule. So the only thing we can use for such amount of length is a measuring tape. So we can use a measuring tape in here. Then in order for us to measure a diameter of 0.4 millimeters, this is a very small diameter. So for this diameter, we can use a micrometer screw gauge. So our answer here is choice C. So for the length, we use a tape measure, then we use a micrometer screw gauge for the diameter. Alright, we proceed. There is another question here, question 2. Question 2, we have question 2 there. So the following diagrams show a measuring cylinder and a balance used to measure the density of liquid X. So we have a liquid here, and that liquid is liquid X. So this is where liquid X is. Then the question is asking us what is the mass and volume of the liquid. Before we can even look at the multiple choices, let us try to find the mass and the volume. So let's start. So we have a beam balances here. Then we have a measuring cylinder. So I'll start by finding the mass of liquid X. So without the liquid here, the mass is here. So this is where the pointer is. If this is 0, 10, 20, 30, 40. So at this point, this is 20 grams. This point, this is 20. So the 20 is the mass of the measuring cylinder without the liquid. Then after you pour in the liquid, which has this volume, so this is the volume of 60 milliliters. After you pour in the liquid with a volume of 60 milliliters, the mass has moved to, so this is 120, 130, 140. So the mass has moved to 140. So this is where it is. So this is 140 grams. So now, what will be the mass of the liquid? So to find the mass of the liquid, we subtract these two masses. The mass of the cylinder, subtract it from the mass, the total mass. So we're going to say 140, subtract 120. And this is just 20 grams, not 120. So we have, so that one is gone. So we're saying 140 subtract 20. So this one should give us 120 grams. So this is the mass. Then volume is 60 milliliters. So we check for the one which has a mass of 120. and the volume of 60 milliliters. And our answer choice is choice B. B is the answer. Proceed. Look at the other question. So we have a question there. So from looking at that one, so the question we're going to look at now is question 3, and we have our question 3 there. Question 3. The following diagrams show an unstretched spring of 10 centimeters and a stretched spring of 22 centimeters when a force of 4 Newton is applied. So that is what we have. Okay, let's see what's happening. Calculate the total length of the spring when a force of 6 Newton is applied. Now look at it. Without any force here, when no force was applied, so let's say 0 newtons, this is the length, 10 centimeters. Now when a force of 4 newtons is applied, it has moved to 22 centimeters. So what's the difference between 22 and 10? So the difference here is, if we say 22 subtract 10, we get 12. So 12 centimeters is the difference. So the length that the spring has moved when a force of 4 newtons was applied is 12 centimeters. So the question is saying, calculate the total length of the spring when a force of 6 newtons is applied. So 6 newtons is applied. So now, here we have 4 newtons. What if we remove the 4 and we put a force of 6 newtons? What is going to happen? So meaning, these 6 newtons would mean just adding a 2 newtons to the 4 so that it becomes 6. Now look at, we said for the 4 newtons it is 12 centimeters. What of the 6 newtons? So if 4 newtons is 12 centimeters, it simply means per each 2 newtons. So if I divide the 12 by 2, I'll get 6 centimeters. So it means per each 2 newtons, it will give a distance of 6 centimeters. So now since it will be 6 now, I'll now look at what I'm having. So I've got 6 and another 6. So I'm going to add them. So I've got a 6 here. And I'm going to say plus another 6 here, then plus another 6. So meaning this is going to give me a total of what? A total of 6 plus 6, 12, 12 plus 6 is 18. So this will give me a total of 18 centimeters. Now, the 18 centimeters is only for the 6 newtons. So in order for me to get the total length, I need to add back the 10 centimeters. So 18 centimeters, adding back the 10 centimeters will give me a total of 28 centimeters. So 28 centimeters is the answer. So I come in the multiple choice and I check if I'm going to find 28 centimeters, and there it is. So 28 centimeters is the total length. Proceed. Look at question 4. A motor is used to lift a load of 400 newtons through a height of 12 meters in 20 seconds. What is the efficiency of the motor if the input power is 300 watts? Okay, efficiency will be given by we have the power output, so the power output over the power input. So that will be the efficiency. So this one is actually being multiplied by 100%. So the power output over the power input multiplied by 100%. So now, here they are telling us to say if the input power is 300 watts. Now, do we have the power output? We don't have. Let's put it here. Power is equal to work done over time taken. Do we have work here? So we don't have work. So let's do this. Work is given by force times distance. So when there is work, we have replaced with force times distance. Why? Because we have the force here of 400 newtons. The force is there, and we have a distance of 12. We have the time 20 seconds. So 20 seconds there. We simplify that. So we'll say 0 is gone, and 0 is gone. 2 into 2 is 1. Then I can say 2 into 12, that is 6. Then I now multiply 40 multiplied by 6. So I'll say 6 by 0, that will be 0. Then 6 by 4. Then 6 plus 6 is 12. Then I get 240 for that one. So I get 240 watts. So 240 watts is the power output. So I'll come here and I'll proceed. I'll say the power output is 240 watts. The power input is 300 watts. This is being multiplied by 100%. So the 2 zeros are gone, 2 zeros are gone. Then I'll say 3 into 24, it goes there 8 times. 3 into 0 is 0. Then we have 80%. And the answer is D. Proceed. Look at question 5. Question 5, there it is. The following is a table containing information about particles in different states. Which of the substances is a solid? So what do we know about the solid? So in a solid, the arrangement of particles in a solid, they are in a fixed pattern. So the answer can either be A or C. We forget about B and D. What is the spacing of the particles? The spacing of the particles, they are close together. They are close together. Then the movement of the particles in a solid, they only vibrate. They are not able to move. They are not mobile, but they vibrate. So the correct answer here is C. We go to question 6. If 1200 cubic centimeters of an ideal gas is heated at constant pressure from 27 degrees Celsius to 127 degrees Celsius, what will be its final volume? So this is on gas. So we have this one. The key point here is constant pressure. So what happens when the pressure is constant? So if the pressure is constant, you've just been given volume and temperature, we use this formula. V1 over T1 must be equal to V2 over T2. So this is a formula that we call Charles law. So Charles law, the pressure is constant. So now we start. They've given us 1200 cubic centimeters of volume. So as the first volume, so I'm going to write it. So the first volume we have 1200. Then the first pressure, the first temperature is 27 degrees. But remember, temperature should be in kelvins. So to find this temperature to kelvins, you just say 27 plus 273. And we get 300 K. So this will be 300. This should give us the second volume is what we are looking for. So V2. Then the second pressure, you add 273 to 127 and it gives you 400. Cross multiply. This will be 300 times V2. This will be 300 V2, giving us 1200 multiplied by 400. Then we're going to divide by 300. Even that side we divide by 300. So that will go, that will go. V2 will be equal to, so 2 zeros are gone, 2 zeros are gone. 3 into 3 is 1. 3 into 12 is 4. Then 4 times 4 is 16. So I write 16. Then I add the 2 zeros. So it will be 1600 cubic centimeters. So meaning for question 6, the answer is B. Now proceed. We look at question 7. Question 7, there it is. So for question 7, we have a question: which of the following is not an electromagnetic wave? Well, this was a straightforward question. The one which is not an electromagnetic wave is C, ultrasound. Gamma ray, infrared, ultraviolet are all electromagnetic waves. Only ultrasound is not. So this was a straightforward question. We go to question 8. The following diagram shows a water wave. Which of the following correctly identifies the amplitude, trough, and wavelength? Amplitude, trough, and wavelength. How can we identify that? So now let's do this. This point here, it's called a crest, and this point is a crest. The distance between two successive crests is called the wavelength. So P is wavelength given by lambda. So meaning wavelength is given by P. So the answer can either be B or D. But let's find out. We proceed. The trough is the one which is down here. The one on top is a crest, the one down is a trough. So then the amplitude is the maximum displacement of a wave. So from here to there, I also want you to note also from here to there, we can call this as amplitude. So Q is amplitude. So we start, our amplitude should be Q. So meaning our answer is B. So on question 8, our answer is B. We proceed to question 9. Let's look at question 9. Question 9 reads, what is the upper limit of human hearing? So here they are talking about the sound in terms of frequency, the audible frequency that a human being can hear is between 20 Hz all the way to 20,000 Hz. Now, the upper limit is 20,000. So now since they've given us in standard form, so 20,000 is the same as 2 times 10 to the power 4 because there are 4 zeros here. So the correct answer here is answer D. We proceed. We go to the next question, which is question 10. Question 10 reads, the following diagram shows a ray of light incident on a plane mirror at an angle of 90 degrees. So this is the diagram we have. Which diagram shows the diffracted ray? Now look at this one is going at an angle of 90 degrees like this. Then the diffracted ray should also be at an angle of 90 degrees. It will go in the same direction. It will go in the same line, now in the opposite direction, I mean. So meaning here, C is facing this direction. So it is only A which is going in the opposite direction. So for number 10, A is the answer. We proceed, we look at question 11. What is question 11 saying? So let us see. Let us see question 11. We have question 11 there. A transparent material has a refractive index of 2.0 what is the critical angle of the transparent material? Critical angle is found by the inverse of sine 1 over refractive index. So critical angle is equal to the inverse of sine 1 over refractive index. So it's going to be the inverse of sine 1 over the refractive index is 2, and this will be the inverse of sine 30. So for this one, it's supposed to be the inverse of sine 0.5. The inverse of sine 0.5. And if you get the inverse of sine 0.5, you are supposed to get now 30 degrees. So for number 11, the choice should be A. So the inverse of sine 0.5 should be 30 degrees. Alright. We go to question 12. A steel bar was being magnetized using an electrical method. Which of the following will increase the strength of the magnet produced? Alright. The first thing you should note here is that we magnetize using DC. So magnetizing, we use direct current. So whatever is saying alternating current, forget. Alternating current, forget. So now we have B and D, which is saying direct current. So if you want to increase, so the question is saying increase the strength of a magnet. So if the strength of a magnet is to be increased, then even the direct current should be increased. So the answer choice is D, increasing the direct current passing through the coil. That is the answer. Alright, we proceed. We go to question 13. Question 13 reads, the following diagram shows a steel bar being made into a magnet using double touch stroking method. So that is what we have. So we're saying we have a bar here, we have a magnet here that is being made. So we have two magnets, so there is this magnet and this magnet. Then we have a steel bar here. So this one is going in that direction and this one is going in the opposite direction. So now what do we say? The question is saying which diagram shows the magnet made. So in short, what will be the poles for this magnet made? So if this is a north pole, an opposite pole will be induced at the end. If this is north, then south will be induced here. If this is north, then south will be induced here. So meaning this is the answer that we are going to find. That's the answer we're going to find. So for question 13, the answer is B. We proceed, we go to question 14. Question 14. Following diagram shows a charged polythene rod which is moved near end V of the metal sphere mounted on an insulating stand. Okay, so we have a charged polythene rod here. It's negatively charged. So we have an insulated stand. Alright, so and we have a metal sphere. Now look at what will happen. Which of the following diagram shows the correct charge distribution in the sphere? So first things first, this one is negatively charged. So negative is going to attract positive. So we're going to have positives being attracted here because this one is coming in this direction. And all the negatives in here are going to be repelled on that end. That's the thing. So the only one that shows this type of arrangement is answer choice B. So number 14, the answer choice is B. Proceed. We go to question 15. Question 15, the diagram shows an electric circuit with two identical lamps. So we have the first lamp and the second lamp connected in series to a 1.5 volts supply. Which statement is correct? So let's look at the statements. The first one, both lamp 1 and lamp 2 will light to the same brightness because they are at the same potential. No, they are not at the same potential. B, light 1 lights brighter than light 2 because it is at the higher potential. Now look at this. This is light 1 connected to the positive terminal. So meaning when the current is passing, it will first go to the first lamp, which is lamp 1. So it will pass. So what we are saying is that this will move and first go to that. So meaning this one is going to light with a brighter light as compared to that, because this will be the first one to get that current. So meaning the answer choice for 15 is answer choice B. Alright, we proceed. We go to question 16. The diagram shows a circuit containing two resistors in parallel while one is in series with the 2. The EMF from the battery is 20 volts. Then find the reading of the ammeter when the switch is open and when it is closed. So want to find the reading when the switch is open and when it is closed. What are we going to do? The first thing that we're going to do is that I want us to find what we call the total resistors. So now when the switch is open, we have what we have here is that we're going to remain with this resistor and that other one. When the switch is closed, all the resistors will be effective. So now what are we going to do? So let's start. So I'm going to say open. This side will be open, this side will be when the switch is closed. So when the switch is open, the total resistor will be equal to, we have 3 ohms plus we have that other one 2 ohms. So this will give us a total of 5 ohms. So that is the total resistance. Then what if when it is closed? So it means all these 3 will be effective. So the total resistance will be equal to, we have this, the 3 ohms. Then we're also supposed to get the resistance for these that we have here in parallel. So now let's do this. The two resistors which are in parallel, we're going to find them separately first. To find the total resistance for these which are in parallel, you first multiply them, 2 multiplied by 2, then you divide by their sum. Sorry, this is a 2, like that. So this will give us 3 ohms plus 4 divided by 4. This will give us 3 ohms plus 1 ohm. This will give us a total of 4 ohms. So we have found the resistance when it is open and when it is closed. But the question is saying find the reading of the ammeter when the switch is open and when it is closed. Okay, so meaning they've been asking us to find. So I'll start with when it is open. So when the switch is open, reading on the ammeter reads current. So current will be equal to, what do we get? So current is equal to voltage over resistance. So current is equal to voltage over resistance. The voltage is 20 volts Then the resistance, when it is open, it is 5 ohms. So 5 into 20, we have 4 amps. So that is when it is open. What if when it is closed? Current will be equal to voltage over resistance. The voltage here is what? Still the same, 20. The resistance when it is closed, it is 4. 4 into 20, it is 5 amps. So the answer for number 16 is answer choice C. Right. We proceed. We go to question 17. Now, question 17, we have that the following diagram shows a device that is used to generate electricity. So we have a generator. So this is a generator that we call a direct current generator. It's a DC. Which diagram shows the graph of the electricity generated? Now, the graph for a DC generator goes in this way. It's like that. For a DC generator, the graph is supposed to move in that direction, just like that, in that arrangement. So if we take here, from the answer choices, we have A, B, C, D. The one which is going to work for that one, so this one will be the graph for a DC generator. So that is a graph for a DC generator. Alright, so this was just identifying the graph of a DC generator, no calculations. Question 18. The diagram shows the structure of an atom. Which of the following shows the correct number of protons, neutrons, and electrons? So the electrons are these which are negatively charged. 1, 2, 3. There are 3. The protons are those which are positively charged. 1, 2, 3. The neutrons are those which are not charged. 1, 2, 3. So there are 3, 3, 3. So answer choice B. Alright, we proceed. Answer question 19. Question 19 is a question on radioactivity. So we have that. Which of the following equations correctly shows a fusion reaction? Now for this one, we don't have to calculate anything because you just have to know the equation for a fusion reaction. When two hydrogen nuclei meet to form a helium atom, so this is a fusion reaction. You don't have to calculate anything, you just have to know it. That's a fusion reaction. We go to where the last one, which is question 20. Given that the half-life of thoron is 52 seconds, how long will it take for the activity of the thoron sample to be reduced to 1/64 of its initial value? Now, this one is easier. So let's do this. So we have the half-life. So we have half-life, and we have our sample here that will be reducing. So initially, we have that. So let's say, for instance, so we're going to take, for instance, if we have, we're saying 1/64 of its initial value. So if the initial value here is starting from 1, so if the initial value of this, the sample is 1, let's say 1 grams or anything, we have 1. So we are saying after a half-life of 52, this is going to reduce to 0.5. 0.5. Now let me do this. We have 1/64. What is 1/64? Now, you get your calculator, then you take 1/64 as a decimal, and you're going to discover that 1 over 64 is the same as 0.015625. Okay, so if this has reduced to half of this, another 52 seconds will pass, so it's now going to be 52 by 2, so this will be 104. If another half-life passes, this will reduce again to half, so which is, we just divide by half, 0.5 I mean, divide by 2, so we get 0.25. So this one, you add it to 52, this one becomes 156, like that. Then the 0.25 will reduce again, so you divide it by 2, and it's going to be 0.125. So you add 52 again to 156, 156 plus 52, you get 208. This one again will reduce, so 0.125 divided by 2. So we're going to have something like 0.0625. So from there, you add 52 again to 208. So 208, you add 52, you get 260. Then again, this one will also reduce again. So we have 0.0625 divided by 2. So here we're getting 0.03125. You add 52 again to 260. 260, you add 52, we get 312. Then this will reduce again. So we have 0.03125 divided by 2. So finally we have this 0.015625. Now this that we have is now what they want us to have, this one. So now, how long has this taken? Now so the 52 here is the time, the half-life. So this one was supposed to, initially, the half-life that elapses, this one was supposed to start from here. So this was supposed to start from here. Then the 312 is the final one that we're supposed to have. So these would be the differences. So you just say, initially, let's say if you had a 1 here, now we are saying after a difference, it's supposed to be like this. After a difference, after 52 seconds, we get 0.5. Again, after 52 seconds, that one should reduce, you get 0.25. Again, after 52 seconds, just like that. Then at the end, you should add up all these 52 seconds that you should have. And you're going to find that you're going to have a total of 312 seconds. So the answer for that one is 312 seconds. So that is how we can go about this. And remember, if you're having any challenges in what we've done so far, you can call. For those who might need online tuitions, we have online tuitions where we look at questions from topics. If you don't understand a certain topic, we can look at a topic as a whole and we help you to understand. So you can call this line 0973 then 75. So you can call this line and we can help you in any subject that you're going to have. So that's it for this part. Then the next part will contain section B, and so on and so forth.